Tip number one is related to correct positioning of the views for a parametric model. As you can see, we have two views and they both fit properly in the drawing border and with relation to each other. And first thing that you would notice is that the model is quite simple. That is done because it's much easier to define your views when you have very simple geometry. When you have detailed geometry, it takes time to update the model and it takes even more time to update the drawing. I will switch to the model now and I will change the size. For example, I will change the length to 100, which is 2 times bigger. Then I would switch back to the drawing and update it. So as you can see now, the views are intersecting with each other, and in this case the recommendation is to actually put your models to the biggest size and then define the positions for the views. Alternatively, you can use the view break. To define the view break, I would make a scale a little bit smaller. And then I would choose view break. And important thing about view break over here, you have to define it associatively from the side of the model, and the same for the opposite side. And make sure you have associativity on. I will switch back the scale. And now I can see that views are defined correctly, and if I switch to the model and change it back to, for example, 50, the update doesn't affect the views. Tip number two is to avoid the dimensions which can be later on broken, lose assertivity, or can actually have a wrong misleading value. Over here we have two dimensions and they can probably look correct for non-parametric model, but if the model is parametric, I would switch to the model and then I would change one value. I can see now that these dimensions are no longer relevant. This happens because we have multiple surfaces over here and the dimensions were attached to one of the surfaces. So in case you have a parametric model, you have to make sure that your dimensions are updatable. You can either avoid the dimensions which are attached to features like this, or you can use other techniques which are described in the tip number 3. Tip number 3 shows you how to take the value for the dimension directly from the model. It is used for making sure that your value is always correct, as we have seen from the previous examples. There are other cases when the value can be broken. And before telling the actual story, I should mention two things. First of all, you should consider the implementation of PMI if you are using these techniques often, because PMI usually works better in these cases. And second thing is usually from my experience it is around 5% of the dimensions on the assembly drawing which are getting broken, so it's quite a small value. You don't need to define all the dimensions with the use of this technique. So first solution would be to just use the feature parameters. If I select the operation and then I can select the view, and then from the model I'm choosing the sketch, and I can see that all the sketch parameters are now here in the drawing. And in case you don't have one parameter on the sketch, you can actually define it as a reference dimension inside the sketch. As I can see here, one of dimension is the reference, but despite that, it is shown on the drawing. The second possibility is to connect the model parameter. Over here I would put the diameter dimension, and it now has a correct value because the rest of the model is cut. To connect the parameter, I would right click over here and choose Add Appended Text. Then I would click on 50 and remove everything. Then I will go to Relationships and I would choose Expression. And then Link to Part, and I'm telling the part name. And after this I'm choosing the expression and press OK. So I can see that now the value is correct. All I need to do is to actually remove this extra error. I'm turning off this ones. And as you can see now, the dimension is correct. And it would always show the correct value in case you update your model. Tip number 4. It will show you how to define the sketch view which is updatable and would follow the parametric model. Over here you can see that I have a sketch view, and to make the sketch updatable I would add dimension to the sketch, and here you have to make sure that it is a driving dimension. If I double click it, I can see that the driving is active, and then I can just simply connect the expression using formula, then interpart expression, then I choose the model and I choose the correct parameter. And now my sketch follows the parameter value. And at the same time I can actually change the scale of the sketch, but the dimension is the same. Tip number 5. It will show you how to show and hide annotation based on expression on the drawing. First of all, you have to allow the expressions to be used in the drawing. To check it, we will go to File, Utilities, and Customer Defaults. In the Customer Defaults, you go to Drawing and then to General. And over here, make sure that Allow Expressions was turned on. When it's on, you can just create an expression. For example, I would call it height, and I would give it the value 1. And then I would choose Edit, Suppress Drafting Objects. I would tell the expression name and press OK. Then I would choose the annotation and press OK one more time. So as you can see now it's on the screen, but if I switch the expression value to 0, it would hide. You can use it with connection to the model parameters, and basically if you suppress some configurations on your model, you can suppress the related expressions in the same way. And the last tip, tip number 6, over here I would show you how you should actually position the drafting features. It concerns features like detailed views, section lines, or the view breaks. For example, if you create a detailed view, you shouldn't position it like this because the control point is not connected with the model. So instead of this, you create a detailed view and you select one of the points of your projection, it would connect the end point to the control point of detailed view. And in this case, your border of the detailed view would move with the model if the size of the model changes.